Okay, na? Thank you. Let me start with the definition of a material. What is a material? A material is a substance or mixture of substances that constitutes an object. And material science is the study of materials and their applications. Raw materials can be processed in different ways to influence their properties by purification, shaping, or the introduction of other materials. So, if you take this definition of material, the naturally occurring substances like minerals and rocks, they are considered as natural materials. So these natural materials, that is minerals and rocks, they have variety of uses in the industrial field. Then what is a mineral? Minerals are naturally formed elements or compounds having a definite chemical composition and usually a characteristic crystal system. Minerals, as we all know, they are valuable resources for life support activities of the human population. Minerals are naturally occurring inorganic substances. Every mineral can be identified by several of its physical properties, chemical properties, optical properties. In nature, more than 4,500 minerals occur, out of which about 24 minerals are common. They are commonly seen in different types of rocks, and they make up around 90% of the mineral constituent of the Earth's crust. Earth crust means, crust of the Earth means first 35 kilometers thickness of the Earth is called the crust. Okay, below that crust, we have a region called mantle. Below the mantle, we have a core. Suppose you are staying in your place. From your place, if you go to a depth of 35 kilometers down below the Earth, then you are in the crust region of the Earth. Suppose if you go beyond that, you will enter into the mantle region. The difference between the crust region and the mantle region is that in the crust, everything is solid. In the mantle, all the minerals, they will be nearer to their melting point. Hence, they are neither solid nor liquid in nature. So if you want to reach the center of the Earth, that is core of the Earth, you have to go a depth of 6,371 kilometers. So this is for just information sake, I give you. Now, minerals may be composed of a single element like gold or a combination of elements. Minerals, which are composed of more than one element, they are bound together by chemical bonding. So various types of bonds are seen in different minerals. All minerals formed by more than one element are bound together by positive and negative ions. Minerals, they are formed by various processes. In nature, we have to identify the process from which the particular mineral has formed. And processes will be different from one mineral to the another mineral. And source is different from one mineral to the another mineral. So their growth are controlled by various physico-chemical conditions, including mass balance, role of fluids, temperature, pressure, depth, or other factors of the environment. All these things control the formation of the minerals. The classification of the minerals. In the field of mineralogy, the organizational structure created by J.W. Dana, aptly named as Dana's System of Mineralogy. See, Dana's System of Mineralogy is just like a Bible for the mineralogists. Every mineralogist has to go through this book. And it is widely accepted classification system for the minerals. Dana, he was the first person to classify minerals into an arrangement by composition and structure. The first 5 editions of a system of mineralogy, they were published in 1837, 1844, 1850, 1854, and 1868, and were authored or revised by J.W. Dana often and often. Minerals are first separated into classes by anion. The main classes are elements, oxides, halides, sulfides, carbonates, phosphates, and silicates. There are many subclasses still based on composition. Smaller groups that are chemically similar are often grouped together. So, by the classification of the minerals, especially chemical classification, it has been divided into 10 classes. What are they? Native elements, native metals and alloys, carbides, silicides, nitrites, and phosphides. Sulfides, sulfur salts, sulfur arsenides, and sulfur antimonies. Then halogenides, oxyhalides, and hydroxyhalides. Oxides and hydroxides, vanadides, arsenides, antimonides, bismuthides, sulfides, iodides. Carbonates and nitrates. Sixth one is borides. Seventh is sulfates, selenides, chromides, molybdites, wolframides, and neobites. Eighth is phosphates, arsenides, vanadides, and polyvanadides. Ninth is silicates. And of course, 10th is organic compounds. So, based on the utility, the minerals can be classified into rock-forming mineral, ore-forming mineral, gem minerals, medicinal minerals, industrial minerals. What is the meaning of these rock-forming minerals? See, for the formation of a particular rock, some minerals are essentially required. To give an example, I think all of you might have heard of the word granite. Granite is a rock. It is an igneous rock. It is an igneous plutonic rock that is used as a dimensional stone or decorative stone nowadays. This granite, if you want to call a particular rock as a granite, it should contain certain essential minerals. What are those essential minerals? Quartz is a mineral, Biotite mica is a mineral, K feldspar, potash feldspar it is called. So these three minerals are essentially required for the formation of the granite, plus accessory minerals like spin, zircon, etc. So these minerals are called as rock forming minerals, because these minerals are essentially required for the formation of a particular rock, whether it is a granitic rock or a dolerite or a basalt like that. Next, ore forming mineral. Ore forming mineral means something is extracted from it. For example, if you take chalcopyrite, it's a ore of copper. Copper, iron, sulfide. So copper is extracted from it. Galena, it is a lead sulfide. Lead is extracted from it. So these minerals are called as ore forming minerals. Then there are gem minerals. See, in the whole galaxy of the minerals, in nature, 4,500 minerals occur. Out of which, all minerals, we cannot call them as gem minerals. Because of certain exceptional qualities in them, only few minerals are called as gem minerals. For example, diamond, ruby, etc. Then medicinal minerals. See, nowadays, minerals, they have found a very importance in the medicinal field also. For example, use of apatite, a mineral in dental field, in dentistry. Then comes the industrial minerals. So today's topic of discussion, or elements, we can say. See, it includes minerals like gypsum, halite, lithium, mercury, etc., etc. Then what is this industrial mineral? What are industrial minerals? Why they are called so? Industrial mineral means industrial minerals are geological materials which are mined for their commercial value, which are not fuel like petroleum or coal. They are not fuel, and they are not sources of metal like metallic minerals like copper ore, iron ore, manganese ore. No, they are not that, but they are used in the industries based on their physical and or chemical properties. They are used in their natural state or after beneficiation, either as raw materials or as additives in a wide range of applications. Out of nearly 4,500 naturally occurring minerals, only few minerals, they are useful to the industries. Why these industrial minerals are so important? On an average, the main reason is, on an average, world uses millions of pounds of industrial minerals, such as limestone, clay, mica, asbestos, and aggregates over a period of lifetime. That's why industrial minerals are very important, because they are the building blocks of the certain sections of the society. So the industries that consume minerals mainly include chemical industry, construction industry, metallurgical industry, agricultural field, energy field, fillers and extenders, environmental field, like this. Different industries, they consume a lot of these minerals. Other fields include pharmaceutical fields. They also consume industrial minerals or elements, drugs, cosmetics, food additives, etc., etc. Raw materials, they are of key importance to the chemical industry. Raw materials are in the form of either minerals or maybe rocks or elements. The rocks, I will give you that lecture in my second session, that is tomorrow afternoon. Mineral deposits, they are the key for sustainable industrial production. Manufacturing of chemical products depends on raw materials like oil, wood, minerals, petroleum, metals, water. See, if these things are not there, we cannot produce chemical products. Primarily, chemicals are used to produce plastics, pharmaceuticals, synthetics, etc., etc. Minerals or elements, they are used in metallurgy, pulp and paper industry, textiles, as construction material and fertilizer. The chemical industry helps to overcome the tightness of critical raw materials through improving the exploitation of mineral deposits, improving the efficiency in processing, recycling, and substitution. Carbon feedstocks like oil, gas, coal, renewables, and carbon dioxide, they are the base of organic chemistry that creates about 90% of the value of chemical industry. Some inorganic feedstocks are regarded as critical, like noble metals, some rare earth elements, that means lanthanum to lutetium, indium, lithium, phosphates, etc., etc. So, for this present lecture, the following important elements that we are going to discuss, they are all very important from the point of industry. What are they? They are mercury, potash, phosphate rock, lithium, boron, gypsum, bismuth, fluorspar or fluoride, sulphur, salt. Salt means rock salt, barite, antimony, mica, asbestos, and mineral wool. So these, as all these minerals details, we are going to discuss in the couple of minutes. So we also discuss about the geological occurrence. In the sense means nature, how does it occur? How a mercury occurs in nature? How a lithium occurs in nature? That we have to discuss. And also geographical occurrence, in where this is available in our country. And what are the uses of these industrially important elements? So all these things we are going to discuss one by one. Natural resources occurs naturally within environments that exist relatively undisturbed by humanity in a natural form. A natural resource is often characterized by amounts of biodiversity and also geodiversity existent in various systems. So geodiversity means all rocks or minerals, they are not formed by one single process. Okay, they are formed by different processes at different places and at different environment. Lot of diversity is there in nature. Okay, so the job of a mineralogist or a geologist is to search, is to see for those differences in nature and search for a deposit and explore it and use it in the industrial sector. Now, let us start with mercury. What is this mercury? Mercury, it is also called as quicksilver. It is only the metal which is liquid at ordinary temperature. Geological occurrence, in the sense, how this mercury forms. All mercury deposits, they are formed from what is known as hydrothermal solutions at relatively low temperatures. I will discuss what is hydrothermal solution in the next slide. In the picture, what you are seeing here in this image of mercury, the mercury is the white portion. White portion constitutes the mercury and remaining part is the other minerals. That means it is associated with some kind of rock. Okay, mercury alone does not exist. It has its ore. Along with that, it exists. Hydrothermal solution means they are hot waters circulating in earth crust through fractures. That means below the, I told you, no, first 35 kilometers thickness is the crust of the earth. Below that crust, if you go in the continental area, you will get into a mantle region. So there, all the materials will be nearer to their melting point. So what happens, because of buoyancy, they try to rise up. So they enter through the fractures in the crust. Crust is made up of different types of rocks. If different fractures are there in that rock, these hydrothermal solutions enter there. These hydrothermal solutions, they in certain places bring these mercury. So they eventually create rich metallic fluids concentrated in a selected volume of rock, which become supersaturated and then precipitate as ore minerals. In some occurrences, minerals can be extracted at a profit by mining. See, what has happened in nature is many types of mineral deposits are available. But the thing is that you cannot mine them immediately because mining is a word that is directly connected with economics. See, if you are investing 10 rupees, at least you should get 11 rupees. At least 1 rupee profit should be there. Then only mining is viable. Though we may have very good deposits. See, for example, in the Karnataka, we have gold in Hatti and Kolar. Now, 27 gold deposits have been discovered in the entire Karnataka. But we are not in a position to mine them because if you want to start a mine, it is not a 1 or 2 day job. It's a job of 10 years or 15 years. If you want to establish a mine, you have to do exploration for all angles because you are searching for a thing that you cannot see through your eyes. Everything may be in the subsurface. So our eyes are not X-rays to see what is there below us. So we have to use various techniques. Geochemical techniques are there, geophysical techniques are there, geological techniques are there. So using all those techniques, we try to locate the ore deposit. Then we ascertain how much it is we are going to get it. So that calculation we have to do. If it is positive, if it is profitable, then only we can go for that mining. Okay, so mining, though we may have a deposit, it should work out economically. Then only we can think of mining a deposit. So that means to develop a mine, think that it will take 20 to 25 years. Once you develop a mine, it will last for 100 years. So you can imagine how much generation of jobs and other things will be created. So coming to the geological occurrence of this mercury, it occurs as a replacement deposit in fissure veins. Okay, the only important ore mineral of mercury is cinnabar. Cinnabar is the ore of mercury, and its composition is mercuric sulfide. So geographically, if you take within our country, these type of deposits are found in Kerala, in Kozhikode, in Padagara area. So the main uses of this mercury is they are used in batteries, non-electronic medical devices like thermometers, blood pressure measuring devices. All these instruments dependent on mercury. Compact fluorescent lamps and cold cathode fluorescent lamps, soaps and cosmetics field. In all these fields, this mercury is used. It is a good conductor of electricity. So mercury is used in switches, clutches, radio equipment, and in the recovery of gold and silver also, this mercury is used. Next is potash. What is this potash? It has been known that if one soaked wood ashes in water and then evaporated, the water remains as a strong alkali. It was formerly common practice to treat the ashes in an iron pot so that this alkali became known as pot ash. Okay, then the alkali formed in this way is potassium carbonate and present term is potash. Now that the potash, it has become potash. So this potash is available in nature. Okay, we can extract potash and use it for industrial purpose. So what are the natural geological occurrences where the potash deposits are available? There are 3 modes of occurrence. What are they? One is evaporate marine salt deposit. Okay, evaporate marine salt deposit, then playa deposit, and brines from salt lakes. So in the marine area, the precipitation will be there. As a result, the evaporation will be there, and the salt deposition takes place naturally. In desert areas, we see the formation of this potash. Okay, so they are called as playa deposits. Playa, it is a Spanish word, means shore or beach. It is also called pan, flat, or dry lake. That means it will have a flat bottom depression found in the interior desert basins and adjacent to coasts within arid and semi-arid regions. Periodically, this basin will be covered by water. So what happens if there is any chance for filtration? That water slowly filtrates into the groundwater, it goes below, joins the groundwater system. And if it is not there, means it evaporates into the atmosphere, causing the deposition of salt. As a result, what happens? Deposition of salt takes place. Sand and mud also takes place along the bottom and around edges of the depression. There you can expect this potash deposition. Brines from salt lakes. While the water evaporates from the lake, the salt remains. Eventually, the body of water will become brine because the density of brine is high. Swimmers are more buoyant in brine than in fresh ordinary salt water. Okay, that's why these brine lakes are called as, they are found in Dead Sea and also in the Great Salt Lakes. The ultimate source of water-soluble potassium salts are the potash silicates that are common in nearly all igneous and metamorphic rocks. For example, I will take the example of the river Kaveri. See, the river Kaveri takes its birth from Talakaveri and it travels for a distance of around 800 kilometers up to Pumpuhar till it reaches the sea. See, this river Kaveri, there is a river water, it flows on different types of rocks. Okay, while flowing on the different types of rocks, if the rock contains minerals, which are potassium silicates, okay, potassium, aluminum silicates will be commonly found. Okay, so that means rock-water interaction takes place, okay, all along the course of the river, right? As a result, weathering of these minerals releases the potash. Weathering means it can be physical weathering or chemical weathering. That means disintegration of the rock. Once a rock gets disintegrated and it interacts with the water, then what happens? Whatever the potassium that is present in the water will be carried to the sea as the soluble potassium carbonate. So that is how these potash material is available in nature. So this is used in the manufacture of soap, glass, and pottery industry as a ceramic raw material. And also it is used in fireworks. 90% of this potash is used for paint industry. Next is a phosphate rock. That means it cannot be strictly called as a mineral because it has no definite chemical composition. It could be calcium phosphate or just phosphate like that. It is a secondary deposit formed due to the accumulation of organic remains like bones and by replacement of limestone, calcite, etc. The rock phosphate is commonly termed as phosphatic nodules as it is found in nodular form. If you carefully see this specimen of this phosphate material, we can see the nodules. How this occurs? The ultimate source of all phosphate material, it is from the mineral apatite. What is this mineral apatite? It is calcium fluoride, calcium with fluorine and phosphate. Apatite is very common in most igneous rocks, which make up a large proportion of the crust of the earth. When these rocks weather, weathering means it can be a physical weathering or a chemical weathering. In the case of physical weathering, just a disintegration takes place due to some activities of the rain or wind or anything, water, river, etc., etc. Chemical weathering means because of the interaction with the water, the rock this phosphate material may get dissociated. So when these rocks weather, the phosphate is made available for plant life in the soil or it is carried in solution in the ocean. So the main phosphate deposits, they are found in Tamil Nadu, Pondicherry, and also in Uttar Pradesh area. And as you know, I think this phosphate is very much used in agriculture and it's used in baking powders, water softeners, dental cements, fireproofing compounds. In all these industries, this phosphate is very commonly used. Come to lithium. Lithium is one of the latest metal and it is the most sought metal nowadays. Nowadays, the entire, the Geological Survey of India is searching for lithium deposits in different parts of the country. So its melting point, you know, it is 180.5 degrees centigrade. There are two important lithium bearing minerals which are of economic importance in nature. What are they? One is lepidolite. It is called lepidolite. Lepidolite is nothing but a lithium mica. It is gray or red in color. You can see in the images. Gray colored mica is here, red colored mica is here. They are lepidolites. And its hardness is 2.5 to 3. Hardness here means it is the relative hardness. It is called the scratch hardness. Okay, it was given by Adrija Mohorovic, a mineralogist. That's why this is called as Mohs scale of hardness. That means if you are able to scratch a mineral with fingernail, then you can consider that mineral as a very softest mineral on the earth. If you are able to scratch a diamond or a corundum, okay, diamond you cannot scratch by any other material except the diamond only. Okay, that is considered as the hardest mineral, right? The softest mineral is talc and the hardest mineral is diamond that occurs in nature. Okay, a scale is devised for this. Number 1 hardness means talc. Number 10 hardness means diamond. So here, the lepidolite is a lithium mica. Its hardness is 2.5 to 3. It is found in the rocks called granites and pegmatites. Okay, so most of these rocks, they occur in our continental crust area. So where you can extract lithium if lepidolite mineral is present in them. Another mineral is spodumene. Spodumene is a double silicate of lithium and aluminum. It is greenish white and yellowish green in color, as it is seen from the images you see here. Hardness is 6.5 to 7. It is a bit harder. It is found in granitic rocks, more often in pegmatite veins. So pegmatite veins means hydrothermal solutions that come from deep below the earth, which enter into the fracture systems and deposits these minerals. So we have to search, locate these minerals and extract them. So lithium occurrence in pegmatite bodies are very common especially in mica fields. In our country, Bihar, Hazaribagh district and Mangyar, they are very good producer of this lithium. Bastar in Chhattisgarh, Udaipur, Bhilwara, Jodhpur districts of Rajasthan. In all these places, we will get lithium deposits. You know very well, lithium is used in chemical industry, pharmaceutical industry, glass industries. It is alloyed with magnesium for making light alloys required for aeronautical purpose. Because for aeronautical purpose, most of the minerals that are used are lightweight aggregates. So it is used as one of the material there. Come to boron. Borax and boric acid are the two principal commercial boron compounds. There are 60 different boron minerals and only 7 are used commercially. To name them, borax and kernite, colemanite, sassolite, etc., etc. How does it occur in nature? This occurs as bedded deposits beneath old playas. Playas, I told you, these playas, they occur in the desert regions, especially in the interior of the desert, a basin-like structure where water, if it is filled in that basin, because of the evaporation, some of the water may get evaporated because of temperature, and some of them, they may infiltrate as a groundwater. So what happens ultimately, deposition of the minerals takes place. One such mineral is boron here, along with mud and sand, etc. This also occurs as brines of saline lakes and marshes, and in hot springs and fumaroles. Hot springs and fumaroles means they are natural geysers. I think most of you have heard of the occurrence of natural geysers in the Himalayan region and also in many other countries. Okay, they are nothing but the hydrothermal solutions which come from beneath the subsurface, enter into the fracture system. Okay, and because of their buoyancy, they come up. They come in the form of a fountain in some places and very hot in nature, but contains very important mineralization. Okay, all those minerals will be in, or many of the minerals like boron, mercury, etc. They are all soluble in such hot springs and fumaroles. The places where you will get here is Gujarat, Hoga Valley in Jammu and Kashmir, Sambar Lake in Rajasthan. These are all the places where boron deposits occur. They are mainly used for the manufacture of enamels, tooth powder, in ceramic industry, for glazing pottery, etc., etc. It is used. Next mineral is gypsum. It is a non-metallic mineral. Gypsum is nothing but hydrated calcium sulfate. pure gypsum is colorless. It is a very soft mineral. Its hardness is just 2. You can scratch gypsum with your fingernail. With difficulty. But with a pen knife, very easily you can scratch. Massive varieties of gypsum are known as Asbestos and fibrous or silky variety as satin spar. How does it occur? Common rock salt. The most plentiful mineral is more soluble and does not precipitate until over 93% of seawater is evaporated. For this reason, beds of pure gypsum can form separately from layers of rock salt. Deposits of both minerals occur as a result of the evaporation of seawater. Gypsum is deposited from lake and seawater as well as in hot springs from volcanic vapors and sulfate solutions in veins. Hydrothermal anhydrite in veins is commonly hydrated to gypsum by groundwater in near or surface exposures. It is often associated with minerals like halite. It is sodium chloride. Where this gypsum occurs in our country means in the Garo hills of Assam, in Andhra Pradesh, in places like Adilabad, Guntur, Nellore, Gujarat, in Bhavanagar area, Himachal Pradesh, in Kangra area, Kolhapur, in Maharashtra. In Karnataka, it occurs in Belgaum and Gulbarga areas. In Rajasthan, Ajmer, Barmer, Bikaner areas. In Tamil Nadu, Coimbatore, Ramanathapuram, Tiruchinapalli. In West Bengal, Midnapur. Uttar Pradesh, Dehradun, Nainital, Jhansi. In all these places, there is occurrence of the gypsum, and in some of the places, this is very seriously being mined and is very much widely used in lamp bases, bowls, bookends, and novelties. Fertilizer, it is used in fertilizer, used for structural material such as plaster of Paris, tiles, etc. Next is bismuth. Bismuth, it is a silver white color mineral with a reddish hue. It is a very soft mineral. Its hardness is 2 to 2.5. Bismuth mineral is usually associated with deposits of tin, tungsten, and base metals. So, bismuth is usually found by medium and high temperature hydrothermal solutions. It occurs in the states of Bihar, Rajasthan, and West Bengal, and it is very much used in medicinal preparation and also in cosmetics. In the manufacture of glass, it is used. Bismuth with copper forms the alloy known as bismuth bronze, which are used for making spoons, jugs, teapots. Next is fluoride. Fluoride, it is a very common name given to the mineral form of calcium fluoride, CaF2. Fluoride, in its pure form, it contains 51.1% of calcium and 48.9% of fluorine. It is a naturally occurring mineral. So, one of the identification tips is if you see in the right side, the image of fluoride, you can see the triangles. So, if you see triangles in these minerals, we can, with this color, definitely we can say this is a fluoride mineral. This is derived from the Latin word fluoride fluere, meaning to flow. It occurs commonly as cubical and octahedral crystals. They occur in different colors. Some are pink in color, red in color, and purple in color, etc., etc. And its hardness is 4 according to the Mohs scale of hardness. Where does this fluorite or fluorspar occur? It occurs as fissure veins and as replacement beds in limestones. Okay, that means if you are having a limestone rock, suppose if that rock is deformed, it develops fissures or fractures. Into that, if hydrothermal solutions enters rich in fluorite, then it becomes a deposit itself. That's why fluorite is normally a hydrothermal mineral. So, coming to the geographical occurrence, Baroda, Himmatnagar in Gujarat, Mahashu area in Himachal Pradesh, Jabalpur, Raipur, Durg in Madhya Pradesh, and in Karnataka, Tumkur and Hassan districts, they have fluoride deposits. So, this is mainly used as a flux in open hearth, that is floor of a fireplace, processes of making steel, used in glass and enamel industry, and making microscopic lenses. Gypsum plate. Gypsum plate is one of the 8 to identify mineral itself. It is used very much in optical mineralogy. It is also used for the preparation of insecticides. Next is the sulphur. Sulphur, it was well known even in ancient times when it was referred to as brimstone. The alchemists thought of brimstone as the principle of combustion because of its ability to burn. Sulphur, it is a familiar non-metallic element with a characteristic yellow color. Okay, why it is yellow in color means, yellow wavelengths of light are reflected or transmitted to the eyes, and we perceive this element as the color yellow. All other wavelengths of visible light are absorbed by the material. The yellow color is a very good identification property for the sulphur, which was known as brimstone in ancient times. So, this sulphur is a familiar non-metallic element with a characteristic yellow color. It is soft yet brittle and melts at a relatively low 1130 degrees centigrade, and it has a hardness of 1.5 to 2.5 so that it can be easily scratched with a penknife. Where does it occur? There are three different kinds of sulphur deposits. What are they? Sulphur in the cap rock of salt domes. What is a salt dome? Salt dome is nothing but a mound or a column of salt that has intruded upwards into overlying sediments. You can see in this picture, this is a salt dome. It's a column of salt, that's all. It has intruded. It has intruded. The above is a layer of sediment. It's a sedimentary rock, we can say. So into which this salt dome has intruded. Okay, this happens in a sedimentary basin where a thick layer of salt is overlain by younger sediment of significant thickness. So this upper portion is significantly thick. This is a portion made up of sediments. Below that is a dome. It is in the form of a mound. It is made up of salt. So in the cap rock of these salt domes, that is in these portions of the salt domes, we can expect the formation of sulphur here. So sulphur is found in sedimentary beds and deposits of sulphur in regions of volcanic activity. That means wherever there is a volcanic eruption, it pours out lava. Okay, and also fumaroles. That means volatiles will come out of the volcanic vent. Okay, they contain this sulphur. So once the lava comes out, it will be very hot. When it comes in contact with the cold atmosphere, suddenly cools. Okay, so no time for crystallization. Fast cooling takes place. That's why it becomes a fine grain. So if it contains some sulfur in it, that also gets crystallized. Okay, that is how the sulfur deposits are found also associated with the volcanoes. So these sulfur deposits, they are found in the Godavari and Krishna districts of Andhra Pradesh, Kangra in Himachal Pradesh, Ladakh region of Jammu Kashmir, Alapi in Kerala, Ballari in Karnataka. In certain pockets, sulfur occurs, and Arcot in Tamil Nadu and in Uttar Pradesh, Dehradun and Garhwal areas. It is uses of sulfur is mainly in the manufacture of explosives, refining of petroleum, medicinal preparations, manufacture of sulfuric acid, paper pulp, insecticides, vulcanizing rubber, and gunpowder. Powdered sulfur is used in agricultural fertilizers. Like this, sulfur has many uses. Coming to the rock salt. Rock salt, that means it is a salt in the form of a mineral. Salt is one of the common rock minerals of the earth. This mineral, technically called halite. The mineral is called, rock salt is called as a halite. This halite is easily recognized by its solubility in water, its distinctive taste, saline taste, and the cubic nature of its crystals and cleavage. Okay, cleavage means when you apply pressure on a particular mineral, it breaks in a certain definite direction. Okay, it will have orientation. So it does not develop any cleavage, any fracture. It develops only cleavage. So orientation will be there. So that is one of the identification tips to identify this halite. Halite is generally colorless. You can see the bottom image, colorless halite. And because of impurities, it may appear white, yellow, blue, brown, red. So whatever the color it gets is because of the impurities. Please, I request participants not to talk, maintain silence. There are 4 different kinds of sources of halite or salt deposits are there. They are bedded salt deposits, seawater, and groundwater saline lakes, and prayas, and salt domes. These are all the different geological occurrence of the salt deposits. Geographically, these salt deposits are found in different states of India. Entire thing is listed. In Karnataka, it is in Gulbarga and South Kannada district, we have salt deposit. And also in Assam, Kocha, Lakshmipur, Kurnool in Andhra Pradesh, Gurgaon in this thing, Punjab, in Kerala, Alkalum, Warrior, and Malipuram, etc., etc. So a huge list is given. You can go through it later, right? It is used in food and preservative purpose. You know, the salt. Salt is a raw material used in the manufacture of common chemicals such as soda, sodium bicarbonate, caustic soda. Salt and chemicals derived from salt are used in the manufacture of a variety of products such as dyes, paper, cotton thread, cements. It is also used in medicine and also as a cleanser. So salt, rock salt, or the halite has multi-users in industry. Next mineral is barite. It's also called as heavy spar. Why means it has a very high specific gravity. Its specific gravity is around 4.5. Okay, it is a non-metallic mineral. So it is derived, the term is derived from the Greek word beris, meaning heavy. There are different colors in barite. So hardness varies from 2.5 to 3.5 and a specific gravity is 4.5. Chemically, it is barium sulfate, BaSO4, an insoluble and very inert substance. It occurs in nature as veins and other hydrothermal fillings formed at relatively low temperature. Barite occurs as isolated nodules. Residual deposits of barite are the result of weathering of primary deposits because of its insolubility. That means if a rock undergoes weathering, it gets disintegrated. Physically, it becomes a different pieces that can interact with the water or any other agency, okay, and get into the natural system. So barite, one of the best barite deposits in southern part of India comes from Andhra Pradesh at a place called Mangampet. This is one of the barite occurring area. It is being mined. And Bihar, Singhbhum, Gujarat, Kutch, in Madhya Pradesh, Jabalpur, Orissa, Sambalpur, etc., etc. In all these regions, barite deposits are there. They are mainly used as pigments for paint, manufacture of glass, paper, oilcloth, and cardboard. Next is antimony. Antimony is one of the few metals that expand rather than contract when hardening from the melt. Stibnite, it is sulfide of antimony. Stibnite is the chief ore mineral of antimony. Okay. Most ore deposits containing this metal, they are formed from low temperature hydrothermal solutions at shallow depth. Okay, so at shallow depth means naturally the temperature will be very less. As you go deeper and deeper, pressure and temperature increases in the crust. In the shallower levels, temperature will be low. Okay, so in that region, we can expect the formation of this mineral stibnite, which is the chief ore mineral of antimony. Okay, so this ore, it occurs as fillings in fissures and other rock openings. Okay, so that is how antimony occurs in nature, right? Most of the states, Andhra Pradesh or Himachal Pradesh, Maharashtra, Rajasthan, Uttar Pradesh, and Karnataka. In Karnataka, the district of Bellary, Chikmagalur, and Chitradurga, they contain antimony deposits. It is alloyed with lead and is used. It also imparts hardness and stiffness to lead. Such alloys are fabricated into pipe. So that is how antimony finds its place in the industry. Electric cable sheathing, bullet storage battery plates, pigments, fireproofing compounds, rubber and glass. In all these industries, this antimony is used. Next is mica. Mica is a mineral that is used as a insulation and in electrical industry. Mica is a principal rock forming mineral which forms about 3.8% of the total mineral assemblages in the Earth's crust. All the minerals of mica group crystallize in monoclinic system, but their crystals are usually hexagonal in outline. Mica is valuable for its dielectric and insulating properties and is used in the manufacture of many electronic equipments. And so far, no substitute for mica is found. People are trying to find it out, but none equals the required dielectric strength compared to mica. Piezoelectric quartz crystals and mica plates have a great importance in the industry. Mica finds a ready market as a terminal insulator in many modern appliances, such as heaters, coffee percolators, toasters, irons, etc. For this purpose, either block or mica sheets are used. Mica is a sheet silicate. It occurs in the form of sheets. The automobile industry absorbs a good amount of mica or micanite for ignition coils. Black micas are used in the manufacture of electrical ovens. Black micas means it is called biotite mica. It is used in the manufacture of electrical stoves and furnace windows, etc., gas lamp chimneys, even lamp shades, gas makes, etc., etc. Built-up mica is extensively used in the variety of shapes such as plates, cubes, rods, cones, and bushings. You can see this mica. So it is very much a sheet silicate. It's a sheet silicate. Layer by layer, it occurs. You can peel off the individual layers. See, this is the photograph of the mica taken under microscope. You can see the fish-shaped mica grains in a rock. This is a rock. This is a it is a photomicrograph. So taken under the polarized petrological microscope. So these are all the mica grains. This is how it looks under the microscope. So there is a variety of mica called vermiculite mica. This is a very special mica, the composition of which is magnesium, aluminium, sometimes potassium, hydrosilicate. The speciality of this mica is this contains 18 to 20% of water. So it is a sheets, it can peel it off, individual sheets, like that it occurs. Okay, so since it contains 18 to 20% of water in its interlayers, if you heat this mica, it expands. So once it expands, see, this is the parts and clots of mica that occurs in nature. Once it expands up to, it will have an accordion-like expansion. That means it expands perpendicular to its sheet structure, right? And as a result, it expands to 32 times the original shell. So once it becomes an expanded material, it is called exfoliated vermiculite, exfoliated mica. This has a lot of uses in the industry. Okay, variety of applications for this mica is there. In agriculture, it is used because you can use this as a soil condition. You can put it will absorb, take water and store it. Okay, that way it helps the agricultural growth. It is one of the important material in the aeronautical industry. Because of its lightweight nature, it is used in the manufacture of aeroplanes. More than that, it is used in the disposal of radioactive waste. You know, radioactive waste, it occurs in the form of a liquid. Okay, so how that waste has to be disposed? Because we cannot expose the radioactive waste to the surface or to the atmosphere. So it has to be carefully sealed. What nowadays the people are doing, scientists are doing, they will try to dig a borehole up to a depth of around 1 kilometer. Okay, so they will insert all your radioactive waste into this exfoliated vermiculite and they will put back into the rock system inside the earth. So that is how the disposal of the radioactive waste is also done using this mineral vermiculite. Next is asbestos. Asbestos does not apply to a distinct mineral in the name. It is a commercial name actually. So it has several varieties. All varieties are fibrous varieties. Okay, they differ from each other in composition. The fibers of asbestos are diverse in strength and flexibility, and that's why their usefulness is considered according to the specification in different manufacturing industries. The properties which give asbestos its great commercial value are its fibrous structure. Why asbestos is sought in the industry is because of its fibrous nature. Okay, because of its fibrous nature and its great resistance to fire. Usually, the length of the fiber, it determines the market value for the asbestos. There are many varieties of asbestos are there, and the market value and the usefulness depend entirely on the length and size of the staple fibers for the purpose of spinning of the asbestos fibers. The long fiber grades of fine silky chrysotile, a variety of asbestos, it has high tensile strength and it is most sought in the industry. Coarser and brittle fiber asbestos, it has a very limited use for the manufacture of asbestos sheet and asbestos cement. So there are different varieties of minerals which are of fiber shape, like tremolite and amphibole. Okay, they are very much suited for filtering operations and for similar purpose where a high degree of resistance to acids is necessary. Asbestos is used as brake lining and some others as automobile spare parts. It is also used as for special packing, gaskets and insulating materials. Building manufacturers require asbestos cement. So asbestos has multi-uses. Asbestos fibers of medium length are mixed with Portland cement for the manufacture of shingles, corrugated and plain sheets and different types of asbestos pipes. Short fiber varieties are used as asphalt asbestos for roofing purpose. Like this, asbestos has multi-uses. In automobile industries, clutch facing and brake lining, they require medium-sized asbestos fibers. Asbestos paper and asbestos filters are used in chemical laboratory. Asbestos packings are extensively used in boiler pipe conduits and as insulating material. Asbestos is also used in acoustic insulation, and a mixture of asbestos and magnesia is largely used in steam line insulation. Asbestos medium grade variety, that is short fiber materials, are compounded with various synthetic resins for the manufacture of molded articles and also with asphalts and oils for asbestos cement, tiles and linoleum. Asbestos also finds a ready market in fiberglass industries. The low-grade short fiber asbestos is used for millboards, paper, boiler coverings, mattress fillings, etc. Thus, it appears that all the different varieties of asbestos find a ready market for various industrial purpose. Particularly, electrical industry consumes large quantities of the asbestos. Another important use of asbestos is for the manufacture of asbestos paper, which is manufactured in the same manner as ordinary tough packing paper. Cheaper grade of asbestos is utilized for this purpose, and it is known. Asbestos is also mixed with powdered magnesite. Magnesite is nothing but magnesium carbonate. It is also a mineral, and it will have 85% of the magnesium carbonate and mixed with 15% of asbestos powder. This is what is known as asbestos magnesia insulation, which is a quality refractory material. Asbestos is mixed with asphalt and made into asbestos paint, which is extensively used for plastering of buildings and rooms exposed to acid fumes or sulphurous fumes. The main deposits of asbestos are found in Bihar, Rajasthan, Gujarat, Andhra Pradesh, Tamil Nadu and Karnataka. In Karnataka, Narasimha area is known for asbestos. There are mines that are being, mining is done for asbestos deposits in different parts of the Narasimha area. See, it occurs as a vein, a band-like thing. This band is going, no, this is the asbestos that has to be recovered. So it is very fibrous in nature. Okay, so usually the people who work in the asbestos mines, they are exposed to a disease called asbestosis. That means these fibers, they enter into the lung system and spoils the lungs of many miners there. Okay, for this lot of research is going on, especially in the Libby area of the America, where these asbestos mines are very much active. There, the people who work in that mine, they suffer from these problems. So this is the same image of asbestos, fiber-like. So next is the last part of this one is mineral wool and glass wool. Mineral wool and glass wool, they are synthetic products actually. They are not natural. Containing extremely thin fibers of silicate glass of 1 to 10 microns in diameter. It looks like cropped sheep's wool. The materials are widely used for the purpose of insulation. The insulating properties depend principally on the innumerable minute pores and air circulating passages inside the artificial material, which cover the fibers of wool and prevent the transfer of heat by the process of convection, and at the same time act as an agent to absorb and dissipate the sound waves. Mineral wool includes rock wool, slag wool, glass silk, and silicate cotton. The rock wool is fabricated from natural rock material and is principally made from blast furnace slag. The mineral-based wools of all types are fabricated from molten silicate slags to intense shearing or tensile forces, which draw the silicate materials into fibrous materials. So it becomes a fiber material, thin fiber material. That's why they will be subjected to the tangential stress, that is shearing, and also tensile forces. The fibers thus manufactured at high temperature are cooled down gradually below the softening point after they are formed. Glass wool, glass silk, fiberglass, and silicate cotton are fabricated by two different processes. The materials are fused in an electric furnace and cooled down slowly. These products look like mineral wool in physical appearance. So the raw materials are principally the blast furnace slags, which are composed of silica, lime, alumina, and some amount of magnesia. So some of the wools, they may also contain iron oxides. The silicate content varies between 36 and 45% in glass wool, which is a major component of the wools. Alumina ranges between 5% and 15%. Over and above these ingredients, there may be certain oxides such as iron oxide, P2O5, ZNO, PbO, and some alkalis. The melting temperature is about 1500 degrees centigrade. High quality glass wool contains CaO 16% to 19%, MgO 3% to 6%, Al2O3 12% to 16%, SiO2 52% to 56%, and B2O3 9% to 11%. The standard for mineral wool should be controlled by properties such as adhesive strength, compressive strength, corrosion resistance, coverage, density, moisture absorption, odor emission, temperature stability, and thermal conductivity. Sometimes solid blocks of the insulated products are used as heat and soundproof materials. For some insulation, loose and granulated mineral wools are usually employed. For industrial insulation, solidified boards, felts, or blankets are used. Loose wool and granulated wool are used in the walls of the houses for heat insulation. For all these purposes, this glass wool or mineral wool is used. Cement used for heat insulation of furnaces, boilers, and ovens are fabricated from granulated wool by fixing together after adding some sort of binding material as fire clays or bentonites. Bentonite is a very good binding material. It's a clay mineral. In fact, the materials from the dumps of certain limestone mines and dolomite mines. Dolomite is calcium magnesium carbonate. Limestone is just calcium carbonate. Okay, which are found in Orissa area. They are considered as the best place for the manufacture of mineral wool. So slags may be obtained from the Tata steel plant. So whatever the slag you will get from the steel plant there in Jamshedpur, that can be taken to Orissa, and the material can be converted into a wool, mineral wool. So the rejected materials which contain some amount of dolomite and some crystalline rocks are considered as an ideal raw material for the manufacture of different types of silica wool. So this is a mineral wool, you can see, and this is a glass wool. So this is how by subjecting it to the shearing stress and tension, so they will be drawn into fiber-like thing and made into a wool. You can see the glass wool and the rock wool, which one is better. So both of them, they find a very good market actually. So thing is that we have discussed some of the very important industrial minerals. Without market, these industrial mineral deposit becomes a just geological curiosity. In the sense, we can keep these minerals in the museum and see and enjoy, unless proper market is there for this. So these industries, if they come up, so you can use this one regularly and make it useful. Demand feeds back from the end use market to the end product, to the intermediate end product, and finally back to the mineral supplier. This is how it works out. Geologically, most industrial minerals are widespread. They have enormous reserves and are easily accessible. Economically, development needs less investments. Economically, they are cheaper to obtain, must be closer to the market. The deposit must be closer to the market. Some specialty minerals demand a higher market price than metals. And economically, they should be more effective. Then only there is a meaning for industrial minerals. Technologically needs less processing, needs less energy, less effect on the environment, possesses exceptionally attractive properties for the industry. If all these things are satisfied, technologically, it makes a very good thing in the industry. So this is the life cycle of a mineral and metal resources. You can see in the first picture, surface mining is done. Then separation of the ore from the gangue is done. The gangue minerals means waste minerals. Suppose if you are having copper iron sulfide, copper is a useful material, you recover it. Other associated minerals like quartz and other things, they are called as gangue minerals. Smelting is done and melting of the metal and conversion to product and finally discarding of the product. So what happens? So you can recycle it and again smelt it. It means melting is heating to release metals but creating air pollutant by products. Chemical removal process such as using cyanide to remove gold can create toxic holding bonds. That is the thing. So to conclude, minerals are natural resources and are wasting assets. Sorry, spelling mistake is there. It is wasting asset. That means once you remove a deposit means you cannot grow it. It is not like that. So it is a wasting asset always. So you have to carefully use that one. Such natural resources can be used at once. So once you can use it, that's all. Minerals are widely used in chemical industries due to its increase in demand and extended supply. Most of the minerals, they are used in chemical industries due to its utilization in the preparation of chemicals, fertilizer, fluxing agent, metallurgical purposes, etc., etc. The chemical industry is the key enabler of sustainable industrial production on a reliable raw materials supply at competitive conditions. So this is how the industrial minerals finds a very important role in the different industries. So in order to sustain our society, we need the utility of these industrial minerals.
Thank you, sir. Thank you very much.
So if you are having any queries, please feel free to ask me. So whatever that is, because what I understand is you are all from different disciplines. I am basically a earth scientist or a geologist. As a geologist, I have spoken to you. Hope it has reached you. I believe that whatever the information which I have given, it has reached you people. So,
sir, we will be very much thankful to you if you provide the soft copy of your PPT.
Sure. I will give it to the center. I think these people will send it to you.
Provide us.
Okay.
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 Thank you, sir.
Okay, welcome. So anything is there? If you are in,
Sir, thanks.
Okay, welcome, welcome.
It's our proud privilege and honor to listen you, sir. You have beautifully explained the difference between minerals and materials, and you have enlightened various materials such as mercury, sulfur, etc., etc.
Okay, okay. Thank you very much for your kind answer. Okay. All right.
Thank you, sir.
And next tomorrow afternoon, I will be taking industrial rocks. How certain rocks are used in the industry. So that is a part of this refresher course. Okay.
Thank you, sir. I have one question.
So if no queries are there, we will end up this session. Okay. Thank you very much.
Sir, may I ask you one question?
Please, please.
Thank you, sir, for your very nice and informative presentation. Sir, you have mentioned in the presentation that diamond is the material that have very highest strength.
Right.
But we know that we have heard boron carbide is another material.
Correct.
That is even hardest than diamond. Is it not available in the ore form?
No. Thing is that whatever you said, the silicon carbide, boron carbide, they are all synthetic material. They are not available in nature, like diamond. Okay, that is the difference. So increasing the hardness, people have produced these silicon carbide and other things. Okay, but naturally only diamond occurs.
Okay.
And it will have a covalent bonding. So carbon atoms are tightly packed with each other. So that is how its hardness has it has come to the diamond. Okay. Please, anything? So please feel free to ask any doubts. If I know, I will return. Okay, I will come back. Okay.
Sir, I have a question, sir.
Pardon me?
Sir, how do you determine the composition of any newly found rock?
Okay, correct. It's a good question. The thing is that rock we can identify in various ways. One way is physical identification. That means what are the certain physical properties will be there for a rock. Okay, that we have to identify. In addition to that, we identify the different minerals present in the rock. So different minerals present in the rock we can identify in a megascopic form. That means in the hand specimen or in the field, if you take a rock, we can identify what are the different minerals, provided you know the properties of those minerals. Sometimes it is very difficult to identify in the field also. Then what we will do means we will make a thin section of the rock. That rock will be ground into 0.001 mm and it will be mounted on a glass plate and we observe under the microscope. So in the microscope, we determine the properties of different minerals. So based on the properties, we identify individual mineral. So if these minerals are present in a particular piece of a rock means, oh, this is this type of rock. Like that we identify. Nowadays, very advanced techniques have come. Even you can determine the chemical composition of a point in an individual mineral. For example, you make a slice of the rock, thin slice of the rock, which you can observe under the microscope. Then using EPMA, what is known as electron probe microanalyzer. The electrons are made to fall on the individual mineral's point, and it will give the composition of that particular point. What is the content of SiO2, Al2O3, FeO, MgO, Na2O, K2O, TiO2? In that particular point, you can obtain. This is what is known as electron probe microanalyzer. That means chemically we can understand, oh, because of this chemistry, this is the mineral. So because of this optical property, this is the mineral. Because these are the physical properties, oh, this is the mineral. That individual minerals are identified. And then once you understand, oh, these minerals are present in an aggregate means, oh, this is this kind of rock. For example, if a rock contains quartz, mica, and potash feldspar, we say, oh, this is a granite rock, like that. So this you can identify physically, optically, chemically. Using all these properties, we can identify them.
And sir, are there any natural occurring nanomaterials and can they be extracted easily?
No, it is not that easy. See, the thing is that maybe some of them have tried. So nano particles are in natural material are there, showing, for example, different gold. Gold is yellow in color, but the nano part of it will be orange in color. So color differences will be there. People are working on it. It is very difficult, but they have recovered. They have recovered such type of material in the natural specimens also.
Thank you, sir.
Okay, welcome.
Yes, it is seen that the shell of the snail, it is made of nano calcium carbonate or nano calcium oxalate. That's why the hardness of the shell is very high. It is
which one, sir?
Very
shell,
hard.
Shell
of the snail.
Shell of the snail. Okay.
It is made of nano calcium carbonate. That's why this shell is extremely hard. It is nano material is available in nature. It is made of nanomaterials.
Okay, possible. See, nanomaterial, if you observe to that scale, definitely the occurrence of that one is a possibility thing. Because in these natural materials, not much work on the nanoscale has been done. Because now the latest is we can identify the presence of the rare earth elements in a rock. That means what is the concentration of rare earth elements in a rock we can obtain. That will be in ppb level. Okay, so now that is the thing, and now people are working. They are trying to know the nano level composition of these minerals. See, for example, meteorites. Meteorites means they are extraterrestrial objects. Okay, they are between Jupiter and Mars. These meteorites, they are nothing but the chunks of the rocks. Okay, whenever they come into contact with the gravity of the earth, they fall onto the surface of the earth. Okay, when they fall onto the surface of the earth with great pressure, they will hit the surface. As a result, because of temperature and pressure, some nano diamonds have developed. Micro level and nano level diamonds have developed. In some of the areas, it has been found. And that possibility, like that, the formation of these things will be a possibility.
Sir.
Yes, sir.
Sir, what about the thermal properties of these materials in nanoscales?
That is I have not tried with that one. So thermal properties at nanos is, I think the people working in pure material science, they may be able to understand this or answer your question.
Okay, sir.